Hey everybody. Today I'm undertaking a difficult and exciting data visualization challenge, working to recreate this famous visualization by scholar, activist, and polymath W.E.B. Du Bois. He made this for the 1900 Paris Expo, and it was designed to show the progress of black people in America in the last quarter of the 19th century following the end of chattel slavery in America. I'm going to be working to recreate this with modern tools. I want to get as many aspects of this right as I can. For some of the historical context, including some of the use of antiquated language in this visualization and others by W.E.B. Du Bois, I had a wonderful opportunity to talk with scholar and historian Courtney Joseph. I'll throw a link to that up top. We talked for about 40 minutes on all of this and got a lot of context for this and other visualizations by this individual. Please check that out. So I'm going to be working in R, of course. Normally I sort of live code when I do these demos. Today I'm just going to walk you through some of the code I did. This ends up being about 300 lines, and giving my typing speed and my the rate at which I tend to make typos, I thought it would be better this way. I've loaded up Tidyverse, and I've typed in manually the data that we have here. I've included the values, the colors, and the way I want to label these. So these are going to be strings. Looking back at this visualization, it really contains all the information we need to recreate the plot. You can see that we have each of these sort of circular type things labeled with numbers that's supposed to represent something like their length or maybe the angle that they span. We also see that these are representing the years 1875, 1880, all the way up through 1899, and that each of these dollar values are supposed to represent the assessed value of household and kitchen furniture owned by black people in the United States. Again, we're supposed to see that over time, these former enslaved peoples have really developed noticeable amounts of wealth despite extremely difficult circumstances in the United States. So I've coded that in. I've also coded in some hex codes for the colors I'm going to use. And I could have done that with a color dropper, but instead I found a style guide that I've used for a number of aspects of these plots. And so I'll just jump to that really quickly. I found this on the GitHub page of one Anthony Starks. AJ, if you're out there, thank you for your excellent work on this. And this includes the hex codes as well as some information about the fonts and the dimensions that I'm trying to incorporate as I go through. My goal here is to get as much of the stuff right as I can without being super fiddly about some of the really specific things here. Like, I'm not trying to distress the corners here. Some of you that have even more artistic skill than me will do better at that than I will. Okay. So, first of all, it's worth noticing that this is fundamentally just a bar chart. We have 6 different categories, and we are showing sort of totals from each of those 6 different categories. So the very first thing I want to do is just to make a bar chart with these 6 labels that I have already coded in, and these 6 dollar values that, well, also I've already coded in. So using my data set that I've made, creatively named data, I'm going to put the value, that is the amount of the value of the household furniture, on the x-axis, the labels on the y-axis, so the categorical variable will be going up and down. I'm also specifying the width of those bars so that they will touch each other, and I'm orienting this so that the bars go left and right. Let's see what that looks like. Have you misspelled data? No, I just forgot to command enter on the data set that I typed in earlier. There we go. Now R knows what I'm talking about. I'm going to be fundamentally trying to make things look good for this video in the zoom window from RStudio. So what we're seeing right now. Things are generally going to look really bad or maybe even awful in the viewer window here, the plots pane. Also, if I try and use a GG save command, things aren't going to look so great either. By the time this is all done, once the video is released and I upload my code to GitHub, which I always do, I will have a GG save command that gets the dimensions right included here. But again, just for the purposes of the vid, this is the thing I want to make look nice. Okay, so here's a very rough and ready plot that includes all the same information as in Du Bois's original. We can see the different labels, we can see the different values of that household furniture. We've got 1899 at the top, 1875 at the bottom. That's lovely. The first thing that I want to do is to get that color palette in there. I took all that time to find those hex codes, to incorporate those in my data frame. So I'm going to do that with Scale Fill Manual. And when I add a Scale Fill Manual, I need a vector called values that's going to be a vector of length 6, saying the 6 colors that I should use instead of the default ggplot color palette. And so I've got that here. When I hit Command Enter, things aren't quite going to look like what I want. So first take a look at what I had. 1875 on the bottom, 1899 on the top, smallest bar on the bottom, biggest bar on the top. When I hit Command Enter on that, I'm still going to have the smallest bar on the bottom and the biggest bar on the top, but notice that the colors are reversed. This was exactly the opposite of what I wanted in terms of color, despite the fact that this color, DC143C, red, is corresponding with the year 1899 in my data frame. It didn't work out that way here. Looking back at the original plot, I want 1899 to be in that bright red color. What's going on here is that R is ordering these labels in alphanumeric order. So 1875 as a category is by default going to come before 1899 as a category, regardless of what order I actually enter these in to my data frame in. So the next thing that I want to do is to fix the order of those labels. So I'm taking my data set and I'm using mutate to change one of the columns. I want to change the label column. And I used factor reorder. Honestly, you could use just the reorder command here as well. I've gotten into the habit of using the tidyverse version. And I'm saying I want to reorder the label column. That's the vector I have. And I want the order to go from 1 to 6. So in other words, let the categories be ordered in the order in which I've entered them. And so let's enter that. And I'm going to re-execute that command, of course. But as I do it, I'm also going to add some boundary color. If you look at this plot, there's nothing around the edges. Whereas in the Du Bois plot, you can see there's a little bit of like sort of a pencil line, like black or maybe gray in between them. So I'm going to put in a very thin line, a boundary line of color black here. And once I do this, you can see that now things are how I want. When I've reordered these factors, it has placed 1875 at the top, 1899 at the bottom. Now the colors match up with where I want them. By the way, I'm happy to have 1875 at the top. If you look at the plot I'm trying to recreate, 1875 is ultimately at the top, and so that's a very good thing. Now, fundamentally, the difference between the bar chart that we've just done and the thing that we're trying to get to is just that the x-coordinate that we currently have is actually supposed to be represented with an angle theta. And so that's just a simple coordinate transformation. Well, okay, ultimately it's not going to be simple, but as a very first step, it's just a change of coordinates. And let's go ahead and do that and see what happens, see how it looks. I'm going to make this into a radial plot. And so all I have done is what I have before, and I've added a coordinate radial here and put in a theme void. And so the theme, you know what, maybe I'll even take out the theme void to start. You can just see what that does. So now instead of the bars going from left to right on an x aesthetic, they are going around in an angular aesthetic like a theta, as a theta. The theme void is going to take off a bunch of this mess. Let's see how that works. There we go. We no longer have the gray panel. We no longer have the guides on the side, the axes, and so on. You may have noticed I put start equals negative pi over 12. Let me show you what happens if I take that out. The default for a radial plot is to have it symmetric, so it's sort of got pi over 12 before it starts and pi over 12 before it stops. So there's pi over 6 radians missing of the total of 2 pi radians. Sorry, folks, there's a little bit of math in here. Just deal with it. It's I think when we're doing data visualization like this, a more elaborate sort of generative art kind of project, it really is a great opportunity to increase our skill both in coding and a little bit in our math, our polar coordinates, our coordinate geometry. You'll see me doing a little bit of math through this vid. Just as a quick review, there are 2 pi radians in a circle. So 1 pi radians is 180 degrees, basically a half circle. So pi over 12 radians is 1/12 of sort of a flat angle, a 180 degree angle. Okay, so the thing I would really like to do is to have this radial bar chart that I have go not just around, nearly 1 full circle, but actually, nearly 2 full circles. And so I'd like to have a start of 0 and an end of an angle that's pretty near 2 full rotations. Of course, if I do that right now, I'm going to get some overlap. So what I'm doing in my mind is I'm imagining this plot where instead of having theta go around in a circle, I'm having theta go left and right. And I'm trying to imagine what that will look like. Obviously, the theta is going to go from 0 to almost 4 pi. But as I move from left to right, these bars are actually going to be going down because the y value on my plot ends up corresponding, the plot I did before the actual bar chart, which I'll show you. There we go. The y value here is going to end up corresponding to the radius over here as you go around in that circle. And so as theta increases, I actually need the radius to decrease. What that means is I need to make an angled bar chart. I need to have a bar chart where I still have the widths of these bars representing total, but as I go from left to right, they go further down. So I'm going to need to do a little math to make this happen. I'm not going to do it all like by hand in front of you, but I just want to show you a little bit of my process. What I did is I took this image that I have, this original image, and I imported it into GeoGebra and put it over a grid. So let me show you that. There we are. And I just dragged and dropped it into GeoGebra, put some transparency on it, and then rescaled it. And if you look closely here, you can see that I have done it so that the circular bars start right on the y-axis, and that this lowest one down starts at y equals 20. And the way I got that was that I tried to center this plot as best I could at 0, 0, right here at the origin. And I did that in a way so that these bars would be on the y-axis. When I did that, I was able to measure the thickness of these bars and find out that they all have thickness conveniently of about 1. Lovely. Then this lowest down bar starts at 0, 20, and then 0, 21, 0, 22, and so on. The next thing I tried to do is to figure out, well, how rapidly are they moving inward? And so I saw that this red bar that starts at 0, 20, after 1 rotation is at 0, 14. So every rotation, they're going down by about 6. Now, if you look elsewhere on the plot or at some of the other bars, this isn't exactly consistent as you go around. I mean, this makes sense. Back in the late 1800s, they didn't have access to the same technological tools we do now. Honestly, I think it's kind of amazing how good this plot looks, given that it was done with very, very simple tools at that time that were available to them at the university where they were working. So if every rotation moves you down by 6, that means we can think of this as a slope, change in y over change in theta. I guess I could have put change in radius over change in theta. So the change in radius, or the change in y, every time I go around is -6. And every time I go around in a circle, I go through an angle of 2 pi. Then I said, what's the total amount of turning that I need to do? The longest bar ends at 15/8 rotation. So basically 1 full rotation and then 7/8 of a rotation more. And so when I make my final plot, I'm going to have it so that this red bar ends at that final angle of 15/8 of a rotation. Okay, so let's actually look at the code here. I took that exact slope that I mentioned a second ago from GeoGebra, the delta y over delta theta. Put that in here. Again, that's a slope with respect to theta. And then I'm going to mutate this data frame that I have so that for each bar, I'm going to be able to get the 4 vertices of the bar chart that I want, this angled bar chart. The idea is that I'm going to have to build these bars by hand. There's not a Geom available to me by default, built into R, at least not that I'm aware of, to give me an angled bar chart. So I'm going to have to say what are the 4 vertices for each of the bars that I want. And that's what this code is doing here. So I've taken my angle and I've said, all right, for each of the values that I have, value is in the assessed value of the furniture, make it a fraction of the total value. So for each one of these bars, what's the fraction of this biggest width? So this would be 100%. This would be something like in the 90%, maybe 80, maybe 60, something like that. And then take that as a fraction of those whole 2 rotations. And then, of course, 2 pi is a total rotation. Great. So that is saying instead of the value of the furniture, what's my angle going to be? And now I'm doing for each one of my bars, what's the lower left vertex? So the first bar has lower left vertex 20, then 21, then 22. What's my upper left vertex? 21, then 22, then 23. So basically just adding 1 to all of those. Then the upper right-hand vertex is going to be the upper left-hand vertex, and then it's going to come down some. So remember, m is negative, and it's going to come down by an amount that's proportional to the width of the bar. The lower right-hand vertex is going to be similar, just 1 lower. The lower left-hand value for the x value is always going to be 0, as is in the upper left-hand value. And the upper right and lower right x values are just going to be those theta values. Make sure I execute that. And I also have to execute m because that's included in my data. I'll just glance at the data set that as I've just transformed it now so you can see it. Again, for each one of these bars now, I have a theta. You can think of that as representing the width of these bars right now, although in a little bit it'll be the rotational distance. And then for each one of those bars, I have the y-coordinates and the x-coordinates of those 4 vertices. Again, I'm going to want to be using Geom polygon here. Let's take a quick look at that help file. Now, to use Geom polygon, I'm going to have to specify, first of all, a grouping variable, fill, because I want these to be colored according to a grouping variable. And then for each one of those, I'm going to need to specify a sequence of x values, the x-coordinates of the vertices within each group, within each polygon, as well as a column of y-coordinates. Again, the 4 y-coordinates for each polygon that I want to draw. In this case, just for the ease of data entry, I put in 4 columns for the x values and 4 columns for the y values. In other words, my data has the wrong shape right now. One of the joys of doing a complicated data visualization like this for me is just all of the different skills I get to develop and practice. Here, I'm going to have to do a more complicated pivot longer. What I really want here is a column called x, a column called y, and then another column with the name of something like vertex. And vertex should be lower left, upper right, lower right. And then I should have 4 rows for every one of my labels. So for 1899, I should have all 4 of those vertices that I just mentioned, a column called x and a column called y. All right, so this is a more complicated pivot longer. Here's the code I used for it. First of all, with a pivot longer, you got to specify the columns that you want. And in this case, I want all the columns that have an underscore in it. So the way I always view the calls argument in pivot longer is that these are the places where, these are the problem columns, the things I got to mess with. Then I have to specify the names of the columns that I want to create. And in this case, I want 2 of them, one of which I want to specify by name. Vertex should be lower left, upper left, upper right, or whatever. And then the other column is going to come from the thing before the underscore. And I want R to generate the name of that column using the value it finds here. And that's where this dot is coming in. And so I've said, first make a column, and the name of that column is going to be the first thing that it's going to find. The name of the second column is just going to be vertex. How is it going to know where to draw the line between the first name and the second name? Well, that's provided by the names sep. So that's where it's, that's what this underscore is doing. Let's execute this and see what it looks like. I think it's easier when you actually see it. So view bar data. And let me get my parentheses right here. There we go. Okay, so again, it made a column called X and a column called Y. That's where this dot value is coming from. It's looking at the first part, the thing before the sep of each of these names in my original data set. Bar data also has a column called vertex, and that I actually passed to it. That's the part that comes after the underscore. Okay, so now I've got what I want. Let me show you, finally, this angled bar chart. And it's super basic, but let's see how it looks. This is the outcome of my Geom polygon. So for each level of the fill variable, for instance, the 1875, it has looked at the bar data set, 1875, and found 4 x values and 4 y values. And so it's sort of imagined this ordered pair, x comma y, then this ordered pair, x comma y, and connected them with connected all 4 of those vertices to create a polygon, and then it's filled it according to its label. And you can see then the key on the right, the legend, tells us what color it has used. Let's just get a preview of how this is going to look when I do a Geom radial on it. Again, this is going to be pretty far from where we want to be, but I think it shows the point. So now when I put this as a Geom radial, you can see that as we go around in the circle, the bars are getting closer and closer to the center of this plot. Now, obviously we have a pretty long wish list right now. We are going to remove the panel, we're going to change the colors, the rotation is off, we need this to go around more than once. And then obviously we still need to do some more thematic elements of this, like adding the title and fixing the panel background. Okay, so just one tiny little thing that I can do before I go back to the bars is to have this go around more than once. So I've added this end argument in here, 15 times pi over 4. That's saying that I should go around this circle 15/8 times. 15/8 rotations, 2 pi radians per rotation is 15 pi over 4 total radians. I also put in a theme void to take out that panel background. Now this really is starting to look like that Du Bois visualization. Okay, let's get the color palette back in there. So I'm going to put in this scale fill manual again, just like we had before. I'm also going to add in the boundary that I had before, that very thin black line. Still, just right now, just looking at the diagonal bar chart. I'll add the coordinate radial back in just a minute. The thing that I want to do before that is to get some labels in here. And so that's the next thing. Now, this is coming in with a Geom text. Let me just highlight that. And for my labels, I decided I didn't want to write every label 4 times. Notice that bar data, this data set, has each label 4 times. I don't think it's really noticeable if you put the this label overwriting itself 4 times, but I don't think that's good practice either. So instead, I went back to my original data set that just has them once. And in my Geom text, I put in this other data set. So instead of using bar data, I've overwritten what I'm using here. Data equals the data set. And I've respecified my aesthetics now, where I always want x to be 0. I'm going to have the y coordinate for where I want these text labels to be YLL plus 0.5. So in this data set, YLL starts at 20, goes up to 25, but I want the labels right in the middle of the bar. So if the red bar goes from 20 to 21, I want the label to be at 20.5. So of course, label is an aesthetic. I want there to be a different label for each of these bars. I'm justifying them at the right. So I want, as in this original plot, the numbers to line up on the right. I specified my size so that things would look good when I hit the zoom button. That's something that I'll potentially want to tinker with later. And then I, of course, kept in my original scale fill. Okay, so in my zoomed in version here, you can see I've got the labels where I want them. They are running off to the side, and the size doesn't look quite right here. I picked size equals 2, not so much that they would look great here, but so that they'll look great when I put that coordinate radial back in. So let's preview that. Let's see how that's going to look. Here it is. You can see I've got my labels, so that's great. I'm going to be able to get rid of this this legend on the right. I'm not going to need that anymore. I'm already feeling pretty accomplished, by the way. At this point, I have the color palette. The bars look nice. The labels are corresponding to the original bars. It's starting to have that flavor of that Du Bois visualization. So go us. Now, there are some things that I want to do to make this look nicer. Like, if you look at this compared to the original, like down here particularly, where the bars are kind of ending, in particular for the bigger numbers, it looks kind of weird. And the reason for this is that the Y scale on the axis that I transformed here starts at something like 9 or 8, something like that. And so that means when it transforms it, the transformed bars, when they're in terms of theta, are going to end up very close to the middle of this circle. So the middle of this circle here is going to correspond to something like y equals 8 or 9. So before I institute the coordinate radial, what I'm going to do is change my y-axis to have limits going from 0 to 26 instead of like 9 to 27 or whatever it is. And so that's what this y limit is doing. You can see what it looks like as a bar chart right there, as a diagonal bar chart. All it's really done is to insert some space here on the y-axis. So when I go back to the radial version, that's going to insert some space away from the origin. So let's get that. All right, now it's looking even more like my like the Du Bois version. The next thing that we should do is to try and make this start at the y-axis instead of at pi over 12 or whatever it is. Now, there's any number of ways you can do that. Within the coordinate radial, you can do start and end and fiddle with that even more. I've done a little bit of that to have it start at 0 and end at 15 pi over 4, but if that's all you do, it still doesn't look right. And to fix that, I put in an expand argument in a scale x continuous. And let me just illustrate what this looks like without that first. You'll notice that even though I had start at 0 and end at 15 pi over 4, it's still kind of out here in space. And that's because if I do the bar version of this, there's this padding on the left. So R is trying to make its radial plot have this be theta equals 0 at the left end of the panel. And so I want that to not happen. The alternative to that is just tinkering with the start and end value here more than I would like. So what I did is I put in the scale x continuous so that I don't have that padding on the x-axis. Here's what it looks like as an angled bar chart. The labels now are not shown on this version. When I do put in the coordinate radial again, you can see that things start ostensibly at theta equals 0. Now, I could just be going a little bit crazy. Well, I'm certainly going a little bit crazy, but it kind of feels like this still is a little bit angled to the left. I don't know if that's true or not. And so I'm going to do a very small correction there. I put that it should start at 0.02 radians, and you can decide for yourself if that's necessary. I decided it was. While I'm at it, I decided it would be a good time to take out that legend. So in Geom polygon, I'm putting show legend equals false. By default, when you have a fill aesthetic, ggplot is going to put in a legend telling you what color fills correspond to what labels. I'm saying we don't need that anymore. And obviously the reason we don't is that we've labeled them specifically. Okay, so that's really what I'm looking for. This is the meat of the Du Bois visualization. I'm going to throw in a couple little stylistic elements while we're at it. I want to add a title. So here it is, using the labs command. There we go, assessed value of household and kitchen furniture. Notice that I've used the /n to force a line break in the place where I want it. Also, while I'm at it, I'm going to add this theme command, plot.background equals element rect, fill equals, and then this is going to be that sort of beige color that we see here, at least roughly speaking. Long story short, on the theme elements, inside of theme, you put the theme element you're trying to change, in this case, the background color of the plot. And then that theme element is going to have one of, I think, 4 different varieties. It can either be a text element, a line element, a rectangle element, or I'm forgetting one. And so this will change the rectangular element that is the plot background. And when I zoom in, there we go. All right, last few things. First of all, I would like to get this sized a little better. I would like to get it oriented in the center. You notice in this original visualization, both lines here are center justified. So I should do that. So that's what's going on here. I'm adding a couple more theme arguments. I'm changing my plot title. And again, that's a text element. And so I'm doing a horizontal justification. The 0.5 means it refers to the fact that left justified would be justify it with 0. Right justified would be justify it with 1. So we're justifying it on a sliding scale from 0 to 1. I've said I want it to be bold-faced, and I want it in 9-point font. So there we go. That's looking good. The very last thing I'm going to do here is to change the font. And so that's also within the theme argument that I've made. Now I want to change all of the text to use the charter family. And that's one of the ones that was suggested in that style guide that I just used. Changing fonts is actually a really complicated thing. I owe y'all a video on all of that. For the moment, let's just execute this and see the final version, which is not 100% perfect. If you look back at the original version, quite apart from the fact that it's distressed, you can find several things that are slightly different. But honestly, I think I'm pretty proud of this. Again, just kind of looking back on this, all the different skills that I had to practice in order to do this with ggplot. Not just the math, not just the diagonal bar chart, not just the Geom polygon. I had to change fonts, I had to work with some of these theme elements, I had to deal with coordinate radial at a pretty deep level. I had to think about some of these other arguments that go into scale x continuous and scale fill manual. I had to do some reordering of factors. One thing I just love about data visualization practice and generative art is that opportunity. All right, everybody, I'm going to throw a bunch of links in the comments below so that you can check out the original source of this data, which is the excellent book edited by Whitney Battle-Batiste and Britt Russert called W.E.B. Du Bois's Data Portraits, Visualizing Black America. I'll make sure that the link to that style guide is down here, as well as to my GitHub.